So now let's start with the next problem and the last one actually. So problem P 4.29. It says consider a steady two-dimensional incompressible flow of a Newtonian fluid with the velocity field u and v and w is given. It says that question number 1, does this flow satisfy conservation of mass? So to understand whether it satisfies conservation of mass or not, we need to evaluate and check the incompressible continuity equation. And the incompressible continuity equation is this one: delta u by delta x plus delta v by delta y plus delta w by delta z equals to 0. Now you put the value of u, v, and w and differentiate. You are given the u, v, and w, right? So differentiate, you get this one. So that means the left side and right side is equals to 0. See, this one is goes, so that means 0 equals to 0, right? So that means yes, it follows this incompressible continuity equation. That means it satisfies the conservation of mass. Okay, that's gone for the question number A. So question number B, it says find the pressure field. So find the pressure field Pxy if the pressure at point xy equals to 0 equals to Pa. So for question number B, now we need to find the pressure gradient from Navier-Stokes equation or relation. So this is the Navier-Stokes equation or relation, right? So rho multiplied by u delta u by delta x plus v delta u by delta y plus w delta u by delta z equals to minus delta p by delta x plus my mu multiplied by delta square u by delta x square delta square u by delta y square plus delta square u by delta z square. Okay. Now if we put the value of u and p, no, sorry, u, then we get mu. Rho, sorry, not mu, rho multiplied by u equals to minus 2xy. So you put the minus 2xy. Delta u by delta x. So u equals to minus 2xy, u derivative with respect to x, that means minus 2y. So you get the minus 2y. Now v is y square minus x square. So y square minus x square multiplied by delta u by delta v, y. Delta u meaning minus 2xy. If you derivate it with respect to y, you get the minus 2x. So that's a minus 2x. So plus w. So w equals to 0. That means this term is 0. Okay, equals to minus delta p by delta x plus mu multiplied by, you see, u all are derivative with respect to double x and y and z. And if you look at this, let's say u doesn't have two order of x, right, or y or z. So that means all of them will be 0. So this one 0, this one 0, this one 0. Then we get the delta p by delta x equals to rho. This one will be minus plus. So 4xy square plus minus 2xy square plus 2x cube. So we take the common of minus 2 rho. You should get this value, xy square plus x cube, right? So that's the equation. Now similarly for the y momentum equation, so that's for x momentum equation. Now this is for y momentum from the Navier-Stokes equation, right? So for y momentum relation, all of them will be same actually, except in case of EU, we will use the v. So EU multiplied by dv by dx plus v dv by dy, w dv by dt. Similarly, so w equals to 0, and this one will be 0, z with respect to z, because none of this equation are second order of z, right? But for the v, It doesn't have any z, sorry. And for the x and y, both of them are in a 2 order, right? So if you take the derivative of second derivative of this v, you get -2 +2. This one will get -2 and this one will get +2. So you get rho multiplied by, this is the same actually almost, except yeah, same way that we calculate for this one, equals to this one minus delta p by delta y plus this one is -2 +2. So this one goes 0. That means actually mu is 0. So we get delta p by delta y equals to minus this one. So we get two equations, right? Okay. Okay. So now, okay. So we get two equations, x with respect to x and with respect to y. Now, if you take this equation and take the integrated term, to find the p, we get p equals to the integration of delta p by delta x multiplied by dx with y equals to constant, because we are taking, the integration with respect to x, right? So equals to, you take this one, integrate it, so you get the -2 rho multiplied by x square y square by 2 plus x to the power 4 divided by 4. Now, since we are integrating, so we will have one constant, integrating constant, f of y. Now we need to calculate, we need to find this value of f of y. How? Now we can just, take the derivative of this equation, p equals to this, with respect to y, right? So that, that will be the same as this equation. So you take the derivative of this equation, we'll get delta p by delta rho equals to, you take the derivative, you get -2 rho multiplied by x square y plus, if you take the derivative of f of y, you should get the df by dy, right? Because that's the y function, so it will not be partial derivative, it will be full derivative. So equals to -2 rho multiplied by, this is actually the same as this one, right? As I say, this is the pressure equals to this term. Now we take the derivative of this equation with respect to y, and that should be the same as this one, right? So that's why you put the value dp by delta p by delta y equals to this one. Now we get the df by dy equals to this. So f of y, we integrate it, we get the f of y equals to minus rho by 2 y to the power 4 plus c. So c is the constant, basically. So we need to now find the value of c. To calculate the find of c, you see we had another condition, which is at x at point x equals to 0, y equals to 0, the pressure is PA. So we'll put this condition here now. Okay, so if we know that x y equals to 0 0, then pressure is PA. So pressure P equals to PA, and then we put the value x and y here. Actually, x and y equals to 0 0. So if you put the value of x and y equals to 0 0, so P equals to P. That means P equals to PA, right? And these will be same, and f of y value is minus rho by 2 y to the power 4 plus c. So you put the value that one here. So you get all x and y. So these 0 0 and 0. So c will be PA. Now we know the c equals to PA. We put that value here. So f of y equals to minus rho by 2 y to the power 4 plus PA. I'm sorry. Sorry. PA. So put this Fy here. So we get the full equation. P equals to this. So that is the correlation of P asked in equation 2B. All right, that's it.